Alright, hello everybody. Welcome back again to another edition of Algebra 2. Mr. Anderson here with you tonight, going over some polynomial equations. We're in section 5.5, and as I said, we're going to talk about solving polynomial equations. That's kind of where we're getting to at the end. But what we're going to do is just review a little bit of factoring that we need to have before we can solve some of those polynomial equations. So we're going to review a little factoring first, and then and there is one new type of factoring that we have not gone over before that we'll talk about. So we've got a new one to go over. All right, so let's first of all take a look at our objectives. All right, so first of all, we are going to factor polynomials, as I said, and second of all, we're going to solve the polynomial equations by factoring. So that's where we're going. All right, first of all, factoring overview. Voila. Okay, look at this neat little chart I made here. I've probably drawn this on the board a few times for you as well. But remember, this is just kind of the progression that you're looking for when you go to factor. So first of all, you know, right here, this is kind of like a flow chart coming down. So we're going to, as we come down here, the first thing that we always look for when we're factoring is we always look for a GCF first. So whenever we can take out a GCF, we are always going to do that first. Then once we either find there is no GCF, or if we take out a GCF, then we look to see how many terms are left here to determine what's going on. So first of all, if there are two terms, now what we've talked about before was the difference of squares. Like here, if you have x squared minus 25, and remember how that factors down. I'm not going to really work anything out here, but remember that's kind of an easy one. X plus 5, x minus 5, remember that? So because it's x times x is x squared, and then 5 times negative 5 is negative 25, and the middle term cancels. Sum of cubes and the difference of cubes, this is the new one that we have not gone over before. So I've got a few examples for those in a few minutes here, and we'll talk about those. Three terms, then remember, we had trinomials. That's where you've got, you know, like x squared plus some number times x plus another number, or you've got a number out in front of the x squared. And those factor a little bit differently, and I'll have a few examples for that too. And then, of course, perfect square trinomials as well, where they'll still factor this one of these other ways, but that's where if you see that they're perfect squares, there's a pattern to follow there too. And then lastly, four terms, we do grouping. I've got an example with that. There's also one little slight new thing is you could possibly do grouping with 6 terms as well. I'll have an example there. That's a little trickier, but basically that's the same kind of thing here as with 4 terms. All right, so first of all, trinomials. Just a quick review on these again. Remember, when you've got a trinomial here, and first of all, this is one with no number in front of the x squared. And so it's kind of simple. It's a little shortcut we can do here. Remember, we just look for the number at the end. It's a negative 18. And we say what times what gives me negative 18, but adds up to 3. And in this case, we say, oh, well, 6 times a negative 3 is a negative 18. But when I add them, 6 plus a negative 3 or 6 minus 3, that's 3. So the shortcut there is we can just take those two numbers, 6 and negative 3, and then just plug them right in your answer there. Okay, pay attention to the negatives though. If it's minus 18, it's got to be a negative 18 out here. Second thing though, it makes it a little bit more complicated if you have a number in front of the squared term here. But it's going to be kind of similar, but you go 3 times negative 16, which is negative 48. Then you say what times what is negative 48, but that adds up to 2. And in this case, it's going to be 8 times a negative 6. 6 times 8 is 48. One of them has to be negative. When I add them, 8 plus a negative 6, that gives me my 2. The difference here is we can't just plug them right into the parentheses like we did earlier. This is where you either will, some of you like to take this and rewrite it into 4 terms so you can group it. So you'd say like 3y squared minus 6y plus 8y minus 16. And now you've got 4 and you can group it. And the reason why I grouped it that way was I thought the 6 would go with the 3 and the 8 would go with the 16. So you could do grouping from there, or the other thing is, remember the box method. And so if you do that, you've got 3y squared and negative 16. And then this 8 and the negative 6, again, it's how the 2y splits up. And so you're going to write 8y and negative 6y. It doesn't really matter which one you put where on those two. And then remember, we just take out a GCF here. These both have an 8 in common. These both have a 3 and a y in common. Going up here, these both have a y in common. And then these both have, let's see, 2, looks like. And it's going to be a negative because the box closest has a negative there. So your 2 factors there are 3y plus 8 and y minus 2. And you notice if you FOIL that back together to check it, 3y times y is 3y squared. The 8 times the negative 2 gives you the negative 16, and then your middle terms here, that's negative 6y and 8y, that gives you the 2. So you get the same thing if you do grouping. All right, quick review there. Now, this is the new one. Okay, so we got to talk about this for a second. Sum of cubes and difference of cubes. Remember, sum means adding, difference means subtracting, and a cube just means raised to the 3rd power. So this is kind of similar to our difference of squares. And it's just a pattern. It's really just a pattern that you're going to follow here. So the first one here, that's going to be the sum of cubes. A to the 3rd plus b to the 3rd. Here's how I kind of try to remember it. It's a little harder to remember, but here's what I do. Whenever I've got the 2 here being added, I say, okay, the first parentheses, I'm just going to take 1a and 1b out of both of those. So a plus b. And then in the other parentheses, then, since I took 1a out of here, what do I have left? I have 2 a's left, so a squared, and I have 2 b's left here, so b squared. Then you just kind of have to remember that the middle term is always going to be, an a and a b, and that the sign is going to switch. So it's kind of the same pattern on both, except if you start with negative, when you take out your 1a and your 1b, the first parentheses, it's a minus b. You still have the a squared, you still have the b squared, and you still have the ab in the middle, except for if it starts as a negative, it's going to be plus in the middle. So the sign changed, from the what you started with to the middle term there. So anyway, let's go through a few examples here, but that's kind of the general concept there. All right, here's a few that we got to work through. Now, remember what I said before? We always look for a GCF first, right? So we're going to look for a GCF and be able to find it here. So you notice between these first 2 here, they both have a factor of 3 that we can take out, GCF of 3, and they both have an x squared. So we took out a 3x squared. What's left over? Well, 3 times what is 24? 3 times 8. And then if we took 2 x's out, we still have 3 x's left. And we took out the 3x here, so we have plus y to the 3rd. Okay, that's great. Good start. We took out a GCF. But now if you look closely at what's left here, is we've got 3rd power and 3rd power. You go, this might be something with cubes, a sum of cubes. We just have to check 8, make sure 8 works. If you don't know off the top of your head, and with 8 you might, but with some of these other ones you might not, what you can do on your calculator is go in to find the math button. It's on the left side, kind of right up here. Hit the math button, go down to find the cubed root. Okay, find the cubed root. And so I've got to find my Oh, I'm way up there. Okay. Got to find the cubed root. So the cubed root, remember, looks like that. It's that button there. So hit that button and then put in 8. Type in 8. So I'm finding the cubed root of 8. If that comes out evenly, that means, in this case, let me just do it here, it comes out to be 2. So that means that 8 here is a perfect cube. You can write this as 2, and then of course you have the x there, 2x to the third power, because 2 to the third power is 8. This is the opposite of raising it to the third power, is taking the cube. And then of course this would be y to the third power. All right, so once we figured out what our, remember from the general form there, a and b, in this case the 2x is your a and the y is your b. So when you write your final thing here, well, first of all, don't forget we've got the 3x squared that we factored out from over here. And then remember in the first parentheses it's going to be this thing right here, which is 2x. And since it's plus, it's going to be plus. And then that, which is y. So there's my first parentheses. I take that plus that. Then in the second parentheses, I take this squared. So 2, now remember, it's not 2x squared, it's, how should I say that? It's not the 2 and then x squared, it's the whole 2x squared. So 2 squared is 4, and x squared is x squared. And then down here at the end, you've got the y squared. And then remember what goes in the middle. You take one of each. So you have a 2x and a y. So you have 2x and a y. And then since it started as plus, it's going to be minus. So this would be your completely factored thing there. Okay, that's completely factored down. You took out a GCF, then you did sum of cubes. Okay, like I said, it's you haven't seen this before, so stick with it. And once you kind of memorize the formula there, the pattern, excuse me, it'll be easier. All right, look at the second one. You notice they're both, one's got a 5 and one ends in a 0, so you know you can take out a 5 out of this as a GCF, and you have a y, one y in each of them. So we can take out a GCF of 5y. So what's left is y to the third. Now you go, ooh, well, okay, this is something maybe I don't know off the top of my head. So I just do 320 divided by 5 to see what's left over. Well, it's 64. I took out the y, so I have a z to the third. Now you go, hey, this could be difference of cubes because there's a cube, y to the third power, z to the third power. I have to figure out if 64 is a perfect cube. And so again, remember what we did with the cube root up here? Math, find the cubed root, type in 64, enter, and you know what it tells me? It said the cubed root of 64 is 4. Okay, so what this means is I've got y to the third power, and this would be 4z to the third power. So now when I put this in my final answer here, I've got the 5y, I took out the GCF, the 5y, the parentheses with two things in it, it's going to be the y from here, and the 4z, and it's minus 4z. And then in the parentheses with 3, it's going to be y squared, two of those y's. And then again, it's going to be not 4z to the third, or 4z squared. It's going to be 4, the whole thing 4z squared. So this will be 4 squared is 16 z squared. And then in the middle, you've got the y and the 4z, so that's going to be, so that's going to be 4yz, and since it started as minus, it's going to change to plus. So that's your factored, completely factored polynomial there. Okay, last one. You notice you got x to the third down here. So you go, oh, that's good. X to the third, we know that's a cube. 400, we better check 400, and if you hit math, cubed root, type in 400, enter. You know what it tells you? It said the cubed root of 400 is 7.368 ... It goes on. It didn't go out evenly, did it? So that is not a perfect cube, and so we would just say here, well, you know what? Not possible, or I guess you could say prime. That's prime. So that's kind of what you're looking for there. All right, sum and difference of cubes. Quick review: factor by grouping. We've done this before with 4 terms. We'll do one with 3 here as well. But remember, if it's 4, just group 2 of them. If there's a negative sign in between, make that plus a negative to keep the negative with the 2. Take out a GCF here. They both have an x squared in common. What's left is x plus 5. Here, I'm going to take out a negative 2, and what's left then, since I took out a negative, it's negative 2 times x is negative 2, and negative 2 times 5 is negative 10. So if you just took out a positive 2, the signs would be wrong, and you just have to switch it. Go back and take out the negative and switch those 2 signs. But the key thing here is you want this and this to have the same parentheses, which they do, and so then your final thing there would be x squared minus 2 times x plus 5. Now, one thing you do have to watch out for, notice you still have an x squared here. You want to make sure that that can't be factored any further. In this, this could be difference of squares, but 2 is not a perfect square, so that's as far as we can go. If this would have been x squared minus 4, we could have broken that down again. So you do want to do that if that happens again. All right, with 6 terms then, same concept, except you'll group 3. I've got them set up so I can just group 3 and 3. You might have to rearrange them a little bit. But you notice they all have a GCF of 4. And then they all have an x, so I take out a 4 and an x. What's left? 2a plus b and plus c. And then here they all have a GCF of 3 and a y. And what's left is 2a plus b plus c. And you notice again, between this and this, they have the same parentheses. So we can write our factored answer as 4x plus 3y times 2a plus b plus c. So same concept there, a little bit trickier, but same concept is factor by grouping with 4 terms. All right, moving on. Sometimes you might have to do a couple of things. There are, like whenever you have, say for example like this, y to the 6th or x to the 6th, it could be squares or cubes. And so always do squares first, okay? So that means this could be written as x to the 3rd squared and y to the 3rd squared. Because remember, for difference of squares, remember, when you get your 2 things here and you write it as x to the 3rd plus y to the 3rd, and then x to the 3rd minus y to the 3rd. So now you're left with difference of cubes. So do the difference of squares first, then you can do actually the sum of cubes and the difference of cubes. You can do both of those. And so remember, this is x to the 3rd. Remember our like put a squiggly line here. Remember, when we break this one down, we just did this, it's going to be x plus y, and then remember what's left is x squared, and then it's going to go minus xy plus y squared. That comes from the first one. Then the difference of cubes is going to be x minus y. That comes from here. And then what's left over is, again, x squared, but this time plus xy plus y squared. So that's a whole big long thing there. Okay? So just do the squares first if that happens. And I think in the interest of time here, I've got a second one. I'm going to let that go, but that's going to be the same thing except for 64 we saw already was a cube, and so when you set this up, instead of just an x to the third and a y to the third, this was going to be 4 x to the third squared and y to the third squared, and then you would go through the same pattern here, but I think in the interest of time I'll let that one go. Okay, next. Quadratic form. Sometimes in order to factor something we need to rewrite it in quadratic form, which, remember, quadratic form is x squared plus something x plus a number, or in this case here we've substituted x squared with u. So in an example here, if you have x to the fourth plus 12x squared plus 32, that's not in quadratic form, but I could rewrite it. And so in a sense, instead of having the variable as x, I make the variable x squared. So now I have x squared squared because the variable is x, or if you want to think of it as being u, you've got u squared plus 12u plus 32. Then you can factor it just like we've been doing. Let's look at an example of changing a few of these into the right form. It's really not too bad once you'll get the hang of it here pretty quickly. The key thing is this. Look at this middle term and this other term. In order to even have a chance at this working, this first term has to be twice as much. So if we have x to the third, that should be x to the sixth. X squared, x to the fourth. If not, like here, x to the third and x to the fourth, this won't even work. So this one we would just say this one's not possible. We can't write that in. We can't write that third one in quadratic form. So it has to be that. Basically, here's what we're saying is, in this case, I'm going, well, what if I made x to the third was the variable? So in other words, I'm just going to put it in parentheses to show that it's the variable, not x as the variable. The 9 part stays the same. I just have to be able to rewrite this as this x to the third squared. That's why it has to be double. So I would write this as 2x to the third squared. So you notice the x to the third is the same variable here and the same variable here, but this term is squared and that term is not. So this would be the correct form for it to be quadratic. I still have that 2 out front. I just took and I said I'm going to make the variable x to the third so it can square here, because 3 times 2 is 6, and here you just have x to the third. And then on this middle one here, you might sometimes be able to include a number or part of this coefficient in there too. You notice x squared and x to the fourth. So we know here x squared, we've got, I got the 18. Think about the factors of 12. If you can take one of those factors and square it, and it's one of these factors, then you can include that in there. So in this case, what I thought of was, hey, 2 times 6. 2 times 6 is 12. 2 squared is 4, which is also a factor of 8. So that means in this case, I could make 2x squared the variable, and then I've got a 6 coefficient of 6 out front here. And that means if 2x squared is the variable, it should be 2x squared squared. Is 2x squared squared, is it x to the fourth? Yes. And if 2 squared is 4, what left makes up 8? 2. So this would have to be 2. That's a little trickier with those variables, or with those coefficients there. But you notice the same thing in the parentheses, the same variable, 2x squared, and then 2 times 2 squared is 8, and 6 times 2 is 12. That one's a little trickier. All right, so here's where we finally at. Okay, we're finally at to where we can solve a couple equations, turn them into quadratic form, and then solve them. So here's what we got. Notice x squared and x to the fourth. That has to happen in order for us to be able to do this. So I'm going to say x squared is the variable. And then this would be what? X squared squared. Oops, I forgot the 29 in there. 29. All right, so again, think of this as just being one variable. If it helps you to think of this as being like u squared minus 29u plus 100, then do that. If you can kind of keep it straight with the x squared there, then that's fine. Basically, we're going to factor this. So we're going to say what times what is 100 that adds up to negative 29. It's going to be negative 25 times negative 4. Negative 25 times negative 4 is 100, but when you add them, you get 29. So in this, with the u here, remember that would be like u minus 25 and u minus 4, which we said, well, u is really what? X squared, right? So to get back to our original equation here, and again, if you can just do this straight with the x squareds and not go to the u, fine, do that. But what this really is then is what? X squared minus 25 and x squared minus 4. And then do you remember what we did before when we were solving equations here? Each part has to equal 0. So we can factor this a little bit further down here. This is difference of squares, so this would be what? X plus 5, x minus 5, and this would be x plus 2, x minus 2 equals 0. So then what would make each part equal 0? X here could equal negative 5 or positive 5. You could write it as plus or minus 5. And then negative 2 or positive 2. And again, if you wanted to, you could write that as plus or minus 2. So 5, negative 5, 2, or negative 2. You have 4 answers. That will happen a lot of times. If you have the fourth power, you will have 4 answers. A lot of the times. Not every time, but most of the time. Okay? One more and then we're done. I know this one's running kind of long. Last one. Oops. So again, here we got x squared is the variable. That means this has got to be x squared squared and minus 6 here. So what I'm trying to do is find out what times what is 8, but adds up to negative 6, and so I'm going to say, well, that's a negative 4 times a negative 2. I'm going to try something. Oh, nice. So negative 4 times negative 2 is 8, but adds up to be negative 6. So again, without using the u here, I'm just going to go straight to x squared minus 4 and x squared minus 2. Okay, do you see how I did that? Because remember, you get 1x squared goes here, 1x squared goes there, just like it used to be with the x's. This one we can still factor down to be what? X plus 2 and x minus 2. This one won't factor down. So here's what we can do to find out on this one what we could get for an answer is, well, let's just finish this here first. I'm going to come back to that. So that means here our answer could be x equals negative 2 or positive 2, right? So plus or minus 2. So that's finishing that off. Now let's finish this off. I'm going to go over here. We want to find out what would make x squared minus 2 equal 0. This is where I think we did this before, where you just get the x squared by itself. So you have x squared equals 2. Remember, you can take the square root of both sides. When you do that, that's going to add a plus or minus over here. So that means you're going to have x equals plus or minus the square root of 2. That's going to be your other 2 answers. So notice you still had 4 answers. You got plus or minus 2 here, and plus or minus the square root of 2 on this one. Sometimes when you do these, you might get imaginary numbers with i's if you get a negative under the square root, and we've talked about that before. So got to be prepared for all of that. So a lot of stuff going on here. You know, we'll practice this a little bit, but that's going to do it. Thanks for sticking in there with me tonight. A lot of stuff, and I'll talk to you next time. Bye.